Here's the final packaging of the oscilloscope GPS clock that I put together. We've got a power switch here. We've got the two control buttons, switch 1 and switch 2, to control the menu items on the clock. And we've got an external LED that's tied into the green LED on the circuit board itself that can be set to flash once per second. It can be also set to flash the time in Morse code. When I turn it on, it'll activate the GPS board and also the clock, and now you'll see the green LED starts to flash the current time in Morse code, and the two switches control the various functions on the clock. Here's the back of the unit. There's 4 BNC connectors plus a power connector on the back, so DC power is fed in through the power jack. The GPS BNC is the input for the GPS antenna for the built-in GPS board. And then there's 3 output jacks, X, Y, and Z for the oscilloscope. X is for the channel 1 output, Y is for the channel 2 output, and Z, which is optional, is for the blanking input if your oscilloscope has it. Connecting to the Z jack makes a little clearer display and suppresses some of the bright highlights caused by the action of the microprocessor tracing the image across the oscilloscope screen. And this is just another view of the back panel showing all the connectors connected. I've got the X, Y, and Z connected with BNC cables. Power is connected, and this is the GPS input cable. The GPS antenna I'm using has a small SMA connector, so I'm going through a series of adapters to adapt it into the BNC male connector on the back chassis. And finally, here's another view with the cover off, showing how I've got things wired up on the inside. Again, we've got switch 1, switch 2. On the inside, I've got the clock board itself mounted on the left-hand side. I've got the GPS board mounted on the right. Here's the ribbon cable that connects both power and the various input-output signals going into the clock board. There's an RS-232 set of signals that are transmitted from the GPS to the clock board for time synchronization. The 1 PPS pulse comes out of the connector here. And I'm also tapping off the battery backup that's used for the real-time clock on the clock board itself, and I'm using that for the battery backup on the GPS. That stores and keeps the almanac information and other information needed to achieve a very fast lock on the satellites once the power is turned off. So I'm tapping the 3 volts off that button cell, which is exactly what this board requires. On the front panel, I've got the external LED. What I've done is I've taken 2 conductors from a piece of ribbon cable, and I've tack soldered it onto either side of the green LED down here, since it's a surface mount component. So I'm essentially running those 2 LEDs in parallel. That's not really a good idea because the voltage drops of the 2 LEDs aren't really equal, but it seems to divide fairly equally across them, and it seems to be working okay. Originally I'd intended to pull that chip off and just solder onto the solder pads, but it seems to be working okay as it is. I've got the 2 switches, S1 and S2 for the menu functions, tied into a connector that's intended for an external programmer on here, but the 2 onboard switches here both have traces that go to 2 of the pins on the microprocessor that do dual function as switch functions, but also function in programming mode to use an external programmer, so it's a convenient point to tap off. I have a ground connection that's common with the 2 that's tied into one of the BNC connector channels here. And then I've got a power switch coming from an external power jack on the back of the back panel, and that just applies power to the 2 wires that I've soldered on either side of the normal power jack on the board here. Now the BNC connectors are across the back, so I've got the X, or channel 1, the Y, channel 2, and the Z, which is the intensity control, which is optional, tied into the positive intensity pin here, since I use positive going pulses to suppress the brightness during the retrace intervals when the scope clock is moving from one point to another. So I got into the positive going output hole here. I did solder another cord, a wire rather, that I have coiled up here that goes to the negative going blanking pulse in case I should have an oscilloscope I want to hook this up to that uses that negative going pulse. That can then be just soldered onto this connector and this one removed. So I just put that in place in case I ever were to need it. Now the GPS board uses a very small RF connector, so I've taken a small pigtail, stripped the center and the braid conductors, and I have that soldered directly onto the antenna GPS, also to a little ground lug that's connected here. I did scour the paint off the inside of the connection, so I've got a good ground connection for all of those output connectors. So it's a pretty neat little package, and the whole thing is nicely RF shielded for use in a ham shack. I was finding that with just using a bunch of clip leads, my ham radio, low power ham radio transceivers were getting into the box and distorting the oscilloscope display, but this packaging seems to do a pretty good job of providing RF shielding for it. So it's in a nice little package, and looks a little nicer than having clip leads and wires all over the bench. And here's both the oscilloscope and the control box operating together, so you can kind of see both of them. You can see when I turn it off, the oscilloscope collapses to the small point here, but when I turn it on, it starts sending signals to the oscilloscope. You notice there were a couple of flickering P's on there. That's the GPS starting up and not sending the pulse per second signal immediately to the board. So now the GPS is acquiring the signal. The LED immediately starts flashing Morse code, since that's how I have it set up. So we'll wait here. It'll take about 45 seconds for it to acquire the satellites again and start updating it. Now you see another flicker on the pulse there as the GPS board is busy. Now there it's acquired the signal. It's flashing, meaning it's resetting the clock. Now the clock has been, the internal RTC on the clock board has been synchronized to the GPS, and now I'm getting a flash every 5 seconds of G just above the day of the week under the 24 numeral. And that just indicates that it's getting a signal and comparing it to the clock, and that they're both matching currently. That'll flash rapidly if the clock determines that an update from GPS is necessary. And again, the 1 pulse per second from the GPS board is driving the second hand, so that's perfectly synchronized with GPS to about 50 to 100 nanoseconds, depending on the number of satellites tracked and position error. The 2 buttons up here provide the same functionality as the 2 onboard buttons on the clock board. This will get you into the mode that does the display, and I guess I can run the demo application, since that's what most people do on these demo videos. So let me do that. This is a demo mode that kind of shows the various features on the clock. So I'll let that run for a few minutes. You can customize it with your own name on the clock face. There's a simplified dial, a 24-hour dial, Roman numerals instead of standard numerals, Arabic numerals, digital clock mode, chronometer mode where it shows hundredths of a second, which isn't too useful but kind of cool. Binary clock for if you're really into geek, with BCD digits showing or indication showing the time. Also a hex display of the time if you're really geeky. The upper field above the middle of the clock dial can be configured to show different types of data, including day of the week and and other information. These just show the different combinations. Calibration screen is used to get the voltage division so that the display is perfectly square. This is a terminal mode that can show RS-232 signals coming in from either the GPS port or the serial port. It supports vector graphics like the old vector graphics games of the early 80s. It does have a help screen that can be accessed with switch 2. That's the configuration menu, accessible with the switch number 1. And then it's got a fast forward and fast reverse mode for just fooling around and making it do something interesting. A couple warnings: B, P for pulse per second missing, and the flashing G indicating the GPS time does not match the regular time. That's the alarm clock indication. It's silent, just gives a visual display. It does offset the display a few pixels every minute, the way I've got it set up to prevent burn-in on the oscilloscope screen. And that's pretty much it on the demo. One thing you can see here that I show in my other video, but I'll show it here again quickly, is put day of week here, date. I can change the application to the RS-232 terminal, and here you can actually see the NMEA strings coming in from the GPS board. This is the information that comes in and is used by the clock to update the time. It contains position data, some information about the satellite lock, how many satellites are being tracked, altitude, and of course the time, and the leap second indication, some other things. Some we use, some we don't for this particular application. And to get out of that, you just press into the menu and switch the application back to clock. So that's it. Got it all packaged up in a nice little box and sitting on my desk here as another clock display in